to solve a problem which appeared in the year 2017 JEE main paper. Here is the problem regarding straight line. So let's go ahead and first understand the problem, what we are going to prove it here or going to solve it here. So here it's given that k is a integer and the vertices of a triangle is provided which having an area 28 square unit. Now we have to find out the orthocentre of the triangle. So let's go ahead and see how to proceed so that we can solve the problem easily. Let's go ahead. So first see that here k is an integer and we have to consider or construct a triangle with the given vertices. So here we consider a triangle ABC where the vertices are considered as A, B and C, where the coordinate is given as you seen in the screen. Let's go ahead and take the x-axis, y-axis and put the point A, B and C arbitrarily. Why arbitrarily? Because see that here it is not possible to guess that what will be the form of this triangle easily, because here k is unknown, but we can guess it assuming k is a integer, right? So we assume that k is greater than 0 and based on that we just approximately plot it. Let's go ahead. So here the area of the triangle is provided. So obviously we need to use the area of the triangle formula. So we know that if the area of the triangle is x1, y1, x2, y2 and x3, y3, the area of the triangle is given by this formula. Now if someone is already known, maybe in class 12 if you are seeing this video, so we can use the determinantal approach to calculate the area, but here as we are solving it for class 11, so I use that a triangle formula which we learned in class 10. Now let's go ahead. So see that to solve or to find out the area, we need to identify what is x1, what is x2, what is y3 and all that stuff, right? So we consider those values here. So we consider that x1, y1 corresponding to the point A. So x1 is k and y1 is minus 3k. We consider x2, y2 corresponding to the point B. So therefore it will be 5 and k. And obviously x3, y3, the remaining thing, that is minus k and 2. So now we need to calculate the area of the triangle using the properties of the or area formula of the triangle. Let's go ahead. So here we just put appropriate values in the appropriate place. That's my job. So let's go ahead. So here we just write down that area of the triangle is equal to 1 by 2. x1 is k multiplied by k minus 2, then 5 and obviously 2 plus 3k, and x3, y3 values we need to put in, so just put it in an appropriate place, right? So this step we need to perform, right, very cautiously, because if we misplace the terms, right, little bit, so then obviously we don't get the final result correctly. So always do that very, very cautiously. Let's go ahead. Now we need to simplify that. So we have to do the basic arithmetics. So therefore we can say that it will be half as it is, and then k into k minus 2. So it's k square minus 2k plus 10 plus 5 3 is 15k minus 4k square. Why? Minus 3k and k will give you 4k. So therefore it 4k square. So therefore it will be 5k square minus 2k and 15k, so 13k positive plus 10. So we are able to calculate the area of the triangle very easily. Now let's go ahead. So what is given here? It is given that, right, in this particular problem the area is 28, so therefore this modulus values will be equal to plus minus 28. Now why we consider plus minus 28? Because if the modular sign is open, so if the values in the expression will be plus 28 or maybe minus 28, both cases, right, it will be the same area, right, because the area formula have the modular sign. So in case 1, first we consider the plus sign. So now we just multiply both sides by 2. So therefore 5k square, 3k and 10 is equal to 56. If we take 56 in the left hand side, we get minus 46. So now our job is to solve this particular problem. How we solve that? Obviously by middle term factorization. So see that if we do the middle term factorization, we'll get it as 23 and 10. That's very easy, right? So now we are go ahead and do the basic factorization step by step, and we get the values of k is equal to either 2 or minus 23 divided by 5. So that's it. So we get the values of k for case 1. Let's go ahead for case 2. For case 2, we consider the values as minus 28. And if we multiply both sides by 2 and simplify, we get 5k square plus 13k and 66. Now see that this equation is not factorizable so easily. So first, we have to apply, right, the b square minus 4c, the general equation of solving a quadratic equation. But before applying that, let's try to find out the discriminant for this case. Right here, the discriminant, that means b square minus 4ca. What is b here? 13. 4c is 66 and a is a. So if we calculate that, right, we calculate as d is negative. So therefore the given equation doesn't have any real solution. Right now, we obviously here we are playing with straight line and all that stuff, so k must be real, and it is given that as well. So therefore this case, it's become meaningless. So here sees that obviously then the values of k will be either 2 and minus 23.5. But again, in this particular problem, it is mentioned k is an integer. So as k is an integer, so therefore the only values or acceptable values of k will be 2. So we have to ignore that minus 23 by 5 values. Okay, that's it. So let's proceed further. So first step of this problem is solved now. Now, as k is obtained, so therefore we can get the exact coordinate of the point ABC. So let's first change that. So A is 2 and minus 6. For B, it will be 5 and 2. So replace that. And then for the coordinate of C, it will be minus 2 and 2. That's it. Now observe carefully in the picture, right? Now here sees that, right, the B and C are having the same y coordinate. That means BC, the line or the sides must be horizontal. So that means it's parallel to the x-axis. So that's why we observe that. So therefore we redraw the figure again. Okay, why? Because then maybe the calculation of orthocentre became easier. So we just go ahead and redraw the figure. Now see that in this particular problem, we need to find out the orthocentre. What is orthocentre? Orthocentre means that it's a point of the intersection of the normals drawn from the vertex to the opposite side. So that's why we are dropping two normals here. So first we drop a perpendicular from A to BC, which is namely AP. We drop another perpendicular from B to AC, which is known as BQ. Now observe they are intersected at some particular point, which is S. So therefore S will be the orthocentre, and in this case obviously we see that AP and BC are perpendicular to each other, BQ and AC are also perpendicular to each other. So therefore our job is mostly done. So now we need to find out only the last step, that is how to calculate the coordinate of S. So that's it. So let's go ahead. How we find the point S? So here, to find out the point S, we can easily understand that, right, that for the point S, right, that it is the point of intersection of the straight line BQ and AP. So our job is now to find out the equation of these two lines. So now let's go ahead. Okay, now see that here we need to find out the orthocentre or that point of intersection. So for that we need to find out the equation of the line AP and obviously BQ. So let's go ahead. So see that here BC is parallel to x-axis. So therefore AP being parallel, AP being perpendicular to this line BC, it must be parallel to y-axis. And we know that any equation of a line, right, which is parallel to, right, the y-axis is x is equal to constant. Now this line AP, as it is passing through the point 2 minus 6, so therefore x coordinate in this particular line always constant. So therefore the equation of the line AP can be considered as x is equal to 2. That's it. Now we need to find out the equation BQ. How we do that? See that BQ is perpendicular to AC. So that's why we need to first find out the slope of AC. So let's go ahead and find out the slope of AC. How we do that? It is passing through the 2 point A and C. We know that equation or the slope of the point joining 2 point x1 and x2 y2 will be y2 minus y1 and x2 minus x1. So if we go ahead, we calculate that a1 is equal to minus 6 minus 2, obviously the y coordinate, divided by 2 minus minus 2. So if we calculate, we get it as minus 8 divided by 4, and hence it's minus 2. That's it. So now see that we also, right, know that BQ and AC are perpendicular to each other, and we know that if two lines are given to us and M1 M2 be their slope and if they are perpendicular, obviously if the product of the slopes M1 M2 is minus 1, hence the slope of the line BQ is obviously 1 by 2. Now slope is obtained. Now see that the line BQ is having slope 1 by 2 and passing through the point 5 2. So we can use the relation or the equation of a line having slope m and passing through the point x1 or n is equal to y minus y1 is equal to m into x minus x1. So here m is equal to 1 by 2, x1 is equal to 5 and y1 is equal to 2. So therefore we get the equation of BQ. Let's simplify that. So if we go ahead and simplify it one by one, we get the equation of the line BQ, which is x minus 2y is equal to 1. So now see that the orthocenter will be the point of intersection of the line 1 and 2. So let's go ahead and substitute x equal to 2 in the relation number 2. So if we go ahead, right, we find out that, right, that 2 minus 2y is equal to 1. So by solving, we get y is equal to 1 by 2. Hence, the coordinate of the point of intersection will be 2.5, and hence the orthocenter S will be 2.5, and hence we obtain the correct option as D. So that's the orthocenter, right? So that's the problem. Hope you understood it.